Hello, welcome. As we continue with Algebra 1, we get to start section 9.1. Congratulations on completing chapter 8. Now we get to continue with chapter 9. And in chapter 9, we're going to be talking about polynomials and other related terms. These functions help us to take a look at mathematical modeling and their relationships. And in science and math, we talk about human growth, animal growth, population models can use these polynomials to predict animal and human growth, population, and maybe things or viruses and diseases and parasites that may affect human growth and population and animal population. And actually very similar to what we're dealing with right now with our situation with the coronavirus. Scientists are using polynomials to figure out and try to come up with a solution for a cure or for ways to help us protect what God has given to us here, okay? And our environmental health requires an understanding of the dynamics of population, which the dynamics of the population can be we can use polynomials to help us understand the dynamics of the population of God's creation that God has given to us here. All right, now in polynomials here, we have talked about combining like terms in the past, and terms can be classified as either constants or variables. Right? Constants meaning numbers that will never change. Okay? The -9 here. Variables have the x's, and those will vary, okay, depending on what the value for your x or your y or for L or M that will cause your function to change. If we were to simplify this, we would have to combine like terms. We get x plus 2x is 3x. Here we distribute our 7 through this quantity, right? So we have 7x minus 63. In this one, we can only combine the y's. And so we have 3x plus 4y. Here we have to distribute the 3 through the parentheses, and then after you do that, and then you combine your like terms, we end up with -x plus 17. Same thing here, we distribute the 4 through the parentheses, and then combine your like terms, and we end up with -2x minus 1. Now, a term, as we said before, is a constant or a variable, or the product or quotient of a constant and one or more variables. That's the term. In other words, each of these right here, each of these are products, okay, of a variable with a number, and these each are different terms. And this is an algebraic expression containing 4 terms. We have 1, 2, 3, 4. Okay, then a polynomial is an expression that can be written as a sum of terms consisting of constants, variables, and with non-negative integral exponents, or products of a constant and one or more such variables. So, in other words, now, we mentioned about these before. A monomial is a polynomial with exactly one term. Mono, okay? Binomial is a polynomial with exactly 2 terms. Bi means 2. trinomial, 3 terms, because tri means 3. For y cubed is a monomial because it's only one term. 2x squared plus 3x, this has 2 terms, so that's a binomial. Here we have 3 terms, so that's a trinomial. 1/2 x is a polynomial. Okay, that we can call that a polynomial. It has a fraction, okay, but x cubed y to the negative 2 power is not, because it has a negative exponent. So anything with a negative exponent cannot be considered a polynomial. Okay, the degree of a term is the sum of the exponents of its variables. All right, now let's take a look at all of these here first. Oops, okay, we'll have all these out. Okay, the degree here, 5x cubed y squared z to the 4th. We take the powers, 3, 2, and 4, we add them all up, and we end up with 9. So the degree of this term is 9. Here we have x, or 4x squared y, is 3. Because 2 plus 1, okay, remember y, any variable by itself is considered raised to the 1st power. And so we have 2 plus 1, and that gives us 3. The degree of a constant is 0, okay? A constant is any number, 2, 12, 86, okay? And these numbers are, the degree of them is 0. The degree of a term is the sum of the exponents of its variables. The degree of a polynomial is the highest degree of any term in the polynomial. So let's take a look at some examples here. Okay, we have 3x cubed y plus 2x minus 4x y squared. The degree of this first term, okay, 3 plus 1 is 4. The degree of 2x is 1. And then the degree of this term, okay, is 1 plus 2. That gives us 3. Now, the highest degree is 4. So that's going to be the degree of the entire polynomial. All right, a polynomial, let's take a look. Oh, sorry. Okay, a polynomial is written in standard form when the terms are arranged in order of descending degrees of one of the variables. So in other words, you're going to take the standard form of this polynomial is you're going to take each of these terms and you have to put them in from the largest to the smallest. That's why there's the symbol right here, largest to the smallest. You're going smaller. So our degrees here, we have 3, 2, 1, 0. And this is standard form. Now, evaluating the polynomials, polynomials are evaluated by substituting the given values and following the order of operations. So let's say that we have this polynomial and it says x is 3, so evaluate this polynomial. That means you're gonna plug in 3 for the value of x, okay? And you're gonna have 2 times 3 squared, 5 times 3, and then plus 6. When you simplify all that, you end up with this polynomial is equal to 3 when x is when x is equal to 3, the polynomial equals 9. For the next example, okay, let's say x is -2 and y is 1. So you're going to plug in your values for x and y, we have 5 times negative 2 cubed times 1, and then 2 times negative 2, because x is negative 2. 3 here times 1, and then plus 5. When you simplify all that, we have 5 times negative 8 times 1, 2 times negative 2, and then 3 times 1, and then plus 5. Simplify that even further. You have negative 40 minus 4 minus 3, and then plus 5. And that will give us negative 42. That's the value of this polynomial. Okay, for this polynomial, okay, so to evaluate this one, this binomial, okay, so what is the degree? The degree of this binomial is 8, because we have 3 and 5, 3 plus 5. Here we only have 1 plus 1. So 8 is greater than the 2, so then the degree is 8. Okay, when x is negative 2 and y is 1, then what do we get? Plug in your values, negative 2 for x and 1 for y, and let's see what we get. We have negative 2 cubed times 1 to the 5th power. And then you would simplify all that. So negative 2 cubed is 8, negative 8, right? And 1 to the 5th power is still 1. Negative 8 times 4 gives us negative 32. 2 times negative 2 on this side here, times 1 is negative 4, right? So negative 32 times negative 4 gives us negative 36. All right, now your homework for this lesson is going to be 16 to 32 even. Simple and pretty straightforward. All right, so have fun with those, and we'll be seeing you next time.